In this video, we are going to graph some simple rational functions. Rational functions has a form f at x divided by g at x. Both f at x and g at x are polynomials. So the domain of this one is the denominator couldn't be 0. So g at x couldn't be 0. So we find the zeros of denominator, then they are the restrictions for the rational function, and that is a domain. All real numbers except the restrictions. The zeros of h at x are the zeros of f at x. Unless you have a whole means the f at x and g at x, they have some common factors you can cancel out, and that the common factor cancelled out are the zeros of the other wholes. So we are going to see what it means, and the first thing we want to graph the reciprocal function, that is 1 over x. That is a simplest rational function. So we are going to create a table of values. Sub in x equals -2, we have -1 over 2. Sub in -1, 1 divided by -1 is -1. -1 over 2, sub in here, you have -2. Then if we label this one, go by 1, then you will see -2, we have -1 over 2. So they have the same sign because it's 1 divided by negative give you negative. So it's just -1, -2. So -1, then the point will be -2, -1 over 2, and the -1, y value is -1. So -1 over 2 give you -2. So we connect these 3 points. This is one branch of the reciprocal function, and also we do the positive x value. So 1 over 2, flip it, is 2. 1 divided by 1 is 1. 1 divided by 2 is 1 over 2. So we are going to have 1 over 2, then 2, 1. 2 is 1 over 2. Then we have another branch. And from this function, we are going to see the denominator. We could write it as y equals 1 over x. So the denominator couldn't be 0. Then we are going to draw. This is a vertical line. So this one, the x could approaches to x equals 0, but will never ever cross it. So this one we call it asymptote, vertical asymptote. And because it's a non-zero divided by a number, so y is not going to be 0. So we could draw another line here, and this one, y could get closer and closer to this line, but will never ever cross it. This one we call horizontal asymptote. So from here we could see that the domain is -infinity to +infinity except x equals 0. So the set notation is x belongs all real numbers such that x is not equal to 0. And for the range is y belongs all real numbers such that y is not equal to 0. And x-intercept, none. So there's no point of intersection with x-axis, and also there's no point of intersection with y-axis. So y-intercept none. The holes, so there is no factor cancel out, so there's no holes. And the horizontal asymptote is this y equals 0. The graph will get closer and closer to that one, but will never ever cross it. The vertical asymptote is x equals 0. The parallel line, we don't call this one asymptote. Asymptote is get closer and closer to it, not parallel. This one is not asymptote. So that is for reciprocal function. Then we are going to see how we could, based on the reciprocal function, to graph the rational function. So this one is 1 over x minus 1 plus 2. We could write it as 1 division. So we change this one to same denominator x minus 1, then times x minus 1 to both numerator and denominator. Collect the like terms, we are going to have 2x minus 2 plus 1 is minus 1. So these two equivalent. But we would like to write it in the first form, because once we write it in this form, we could write it as y equals function with subbing x minus 1, we are going to have 1 over x minus 1. So the first term is f at x minus 1, then plus 2. And by writing it in this way, it is compared to the general form, function a times f, k bracket x minus 1, then plus x minus p plus q. Then we are able to find a equals 1. So I will write a equals 1, k equals 1, p equals 1, and q equals 2. So we know that a and k are vertical and horizontal stretch. If 1, it means the graph, the shape won't change. P and q is a horizontal and the vertical translation. So it means the whole graph is going to be right 1 up 2. So all these points, x will plus p, and y is going to plus q. So this is ay plus q, this is x divided by k plus p. They are going to be the new point on the graph. AK same, AK is 1, so xy won't change. You just plus 1 to the x value plus q, 2 to the y value. So we are going to graph it first, then after that we are going to find the domain and range. So this one, we are going to see all these points, or we could graph the parent function first, then move it around. So I'm going to graph the y equals 1 over x first. So 1, 2, 1, 2, 0, negative 1, negative 2, negative 1, negative 2. Then when x equals negative 2, 1 over x is negative 1 over 2. Then negative 1, 1 divided by negative 1 is negative 1. Negative 1 over 2, 1 divided by it is negative 2. So we have this branch. Then we are going to draw this branch. So 1 over 2, 2, 1, 1, 2, 1 over 2. So we graph this parent function first. and we have the two asymptotes. One is y equals 0, another one is vertical asymptote x equals 0. Then from this transformation, we know P is left, right, Q is up, down, so all the 6 points will be right one, up two. So we are going to right one, up two, right one, up two, right one, up two. And the easier way to graph it is we move the asymptote first. So P equals 1, it means this asymptote go to the right, 1. So the new asymptote is x equals 1, and for the y asymptote is up 2, so it's y equals 2. So y equals 2. Then you will see the new points is 1, 2, 3, and I think this one is not perfect, it should be here. The reason for that is this one is 2, so -2 up 2 is on the x-axis. Then we have these 3 points. Then for another one is move it around, so also we could just from here is 1 or 2, then flip 1, 1, 2, 1 or 2. It will be easier to graph that way. So this is y equals 1 over x minus 1, x minus p, then plus q, 2. So this is how you graph it. Then we are going to fill in this one, so the domain and the range. For the new one, we know it is not going to be, the domain will be the x cannot be the denominator couldn't be 0. So we saw x minus 1 equals 0, couldn't be 0, then we have x couldn't be 1. And that is the asymptote, x equals p value. So that is a domain is x belongs all real numbers such that x is not equal to 1. And for the range is y belongs all real numbers. Before is y couldn't be 0, now it couldn't be the q value. So y is not going to be 2. And x-intercept is solve for this 2x minus 1, it gives you 2x minus 1 equals 0, the numerator equals 0, that is your x-intercept. So 2x, move the -1 to other side, is +1, then divide by 2. So you have x equals 1 or 2, that is your x-intercept. And y-intercept is subbing x equals 0. Then y equals 1 over 0 minus 1 plus 2. It gave you 1, so you have 0, 1 is your y-intercept. The wholes, there is no common factor cancel out, so no wholes. Horizontal asymptote, we have it already, is y equals the q value. So this is y equals q. Before is y equals 0, now it's up or down q. And before the vertical asymptote is x equals 0, now it's moving left or right, x equals p. So here is x equals 1. So this is a first graph from the parent function 1 over x. So AK1 and PQ move it around. So So that is for the first graph. Then we are going to see the next one. So we have more graph here, and we are going to see if we are going to have any holes there. So this one, x-intercept is the numerator. So we need to see if there are anything we could cancel out. So factor the x squared minus 1. It's a difference of squares, so we have x plus 1, x minus 1. Then you will see x minus 1, x minus 1, they are common factors, so the final answer is 1 over x plus 1. Then the simplified form, the numerator has nothing there, so it means we don't have the whatever cancel out is a whole. So x equals 1 is a whole. And other than x equals 1, there's no other zeros, so no x-intercept. And for the y-intercept, we sub x equals 0 into the simplified form. You will see it's 1 over 0 plus 1. Give you 1. So you have 0, 1 as your y-intercept. Horizontal asymptote is from the PQ. So the simplified form, we could write it as equals f bracket if f of x is 1 over x. Then 1 over x plus 1 means you sub in x plus 1. Then you have 1 over x plus 1. From this one, we could find our AKPQ. So horizontal asymptote is x equals, is y equals. So horizontal asymptote is this way, so it's y equals up or down, y equals q. The q value is nothing here. This is a 0, so y equals 0 is your horizontal asymptote. Vertical asymptote is this way. X equals a p value. So this p is -1, so x equals -1 is your vertical asymptote. Then we are going to see the next one. So x-intercept, we could simplify this one. So this one 3x minus 6, 3x minus 6. Then add the numerator together. We have 3x minus 4. So x-intercept means after simplified, the numerator equals 0. So solve it. We have x equals 4 over 3 is your x-intercept. And y-intercept always is x sub in x equals 0. So x equals 0, you will have y equals 3 times 0 minus 4, 3 times 0 minus 6. Then you will have minus 4 over minus 6 is 2 over 3. So this is your y-intercept. The holes, there's no common factor, cancel out, so no holes. Horizontal asymptote is y equals q. So we are going to see this one. We could write it as function notation f bracket. The 2 we can take it out. So 2 times 3x minus 3x minus 6, we could factor it, then plus 1. So this one you will have 1 over 3x minus 6, then after that times 2, then plus 1. So we have AKPQ here. Q is 1, so y equals 1. And from here, p is 2, so we have x equals 2. It move to the right 2. And the last one, we are going to do the factoring. You will see we have common factor x minus 1, we could cancel out. Then we have x plus 1, and x minus 1 cancel out is your whole. So x minus 1 equals 0. This 0 is a whole. And x-intercept is a numerator after simplified. Numerator equals 0, so x plus 1 equals 0. And solve it, we have x equals negative 1. And y-intercept is subbing x equals 0. You will have y equals 1. So you have 0, 1 as y-intercept, and negative 1, 0 as x-intercept. The horizontal asymptote means the line that will approach it. But after simplify, you will see we have a linear equation. It's not rational function, so there's no horizontal asymptote. And vertical asymptote is denominator equals 0. Now it's no denominator, so there's no vertical asymptote. So now we are going to see how we can graph it. Okay. So the first one is f at x plus 1 plus 0. So the g at x is 1 over x plus 1, and we could write it as f at x plus 1. So we are going to graph the parent function. Parent function f at x is 1 over x. So it's 1, 2, 1, 2 x y. Then negative 1, negative 2, negative 1, negative 2, 0. So the point is negative 2 sub in is negative 1 over 2. Negative 1 sub in to f at x is negative 1. Then negative 1 over 2 sub in is negative 2. And we draw the asymptote. X equals 0, y equals 0. So this is y equals 0. Another one is x equals 0. Then 1 over 2, 1 divide is this one, 1 divided by 1, 1 divided by 2. Then this is parent function f at x equals 1 over x. Then after that, this p is negative 1, so the whole graph will move to the left 1 unit. Then we are going to draw the asymptote. So left 1, so it means x equals negative 1 is your new asymptote. And y equals 0 is same as before. There's no up down, so y equals 0 is your asymptote, and the whole graph just move to the left 1. So this 1, this is 1, this is left 1. Don't cross the asymptote, then this one you could just think is a u. So move everything to the left 1. Then this is a new graph. So it's g at x equals x minus 1, x squared minus 1. Then we know at x equals 1 there is a hole, so we are going to draw a hole at x equals 1. So then this is a graph for g at x. Then the next one is h at x equals 2 over 3x minus 6 plus 1. So we are going to graph it on the next graph. So we are going to draw the parent function first. This is x, this is y-axis, then go by 1, 2, 1, 2, negative 1, negative 2, negative 1, negative 2. Then we draw the asymptote. So it's x equals 0, y, this is y equals 0, then x equals 0. The graph will never ever cross these two asymptotes. Then negative 2, negative 1 over 2, reciprocal, reciprocal. Then reciprocal, reciprocal, 2 reciprocal. So f at x equals 1 over x. Then we copy h at x here equals 2 over 3x minus 6. And plus 1. So we are going to see this one. We could write it as 2 times function f 3x minus 6 plus 1. Then make sure we factor it is 3 bracket x minus 2 bracket plus 1. Then from the PQ we are able to draw the asymptote. So x equals 2, x equals p is 1 asymptote, vertical asymptote. And y equals q is the new asymptote. And from the x and y intercept, we could draw the graph. So this one, x-intercept is 4 over 3, another one is 4 over 3 is here, 2 over 3 is here. So it's kind of, we could graph it roughly this way, it's okay. Or you could just move the point. Is you need to do the stretch, so it's more complicated. You could just roughly graph the x, y intercept, then sketch it. It will be good. Another one is just sketch it, then it's good. So this, so I will graph it more accurate. So it's kind of symmetric. So this point will be, this is 2, then is 1/3 here. And this one is 4, 3, so it will be up 1, then 4, 3 here. So then connect these two points, and it's done. So this is how graph this one, and the last one, and we don't have any holes for this one, so no open holes. And the last one is x plus 1. So for x plus 1, we could just graph the line. So the last one is y equals x plus 1 with a hole at x equals 1. So from this one, it will be y-intercept is 1, and the slope is 1, so it's 1 over 1, up 1, right 1. Then connect them, but here we have a hole here, so we are going to put open dot here. Then draw a line. So this is a last graph. Lx. So this is L at x equals x squared minus 1 divided by x minus 1. So it's same with y equals x plus 1 straight line, but with a hole, an open dot at x equals 1. So that is all for today's lesson. Thanks for watching.